Thanks a lot. Good morning, everyone, and thanks a lot for attending today. My name is Maximilian Roth, and I'm working at the Fraunhofer-IIS and at the mioty Alliance. And for those who are not that deep into the topic, I will start with a short introduction into the mioty technology. Well, this protocol was developed by the Fraunhofer-Gesellschaft, which is the world's leading organization for applied research. And the core invention, the thing that makes mioty so special, is telegram splitting. This protocol has a number of key advantages over other technologies we have seen in this area. And it has ultra-low power, it has a very high quality of service. So this means it works very well for scenarios where you need long range, a high reliability, and a massive capacity or scalability. And the ecosystem behind this technology is the mioty Alliance. As of today, we have 40 members. And among the full members are Texas Instruments, Swissphone, D-Metering, Vika, Laureate, but also Fraunhofer, to name a few. And one of the main advantages of this alliance is that we have a very close collaboration between well-known research organizations and industry leaders. And together we develop new capabilities to expand in new markets, we acquire projects to increase the revenue for our members, and we set up also strategic partnerships with other alliances, such as the OMS, for example, to increase the interoperability in different market segments. So if this sounds interesting to you, please see me after the talk at our booth or visit our website, mioty-alliance.com. Well, and on the bottom left, you see some of the strategically relevant topics we are working on currently. I'm not going into detail here, but I will put the focus now on sustainability in this presentation. And in many areas, IoT technologies can make a significant contribution to save energy, but also to save resources. And examples are, for example, energy monitoring, water leakage detection, or water level monitoring. But on the other hand, you have also a huge challenge. And IoT technologies also consume resources. IoT devices, gateways, or networks, they need energy for their operation. And with a growing adoption of IoT solutions, also the CO2 emissions will increase. And the question is, how can we tackle this challenge? And there are many options. We are working, for example, on embedded green AI, to machine learning in IoT sensors to reduce the data traffic, or efficient wireless connectivity, especially mioty, but also combination of different technologies, and edge computing to reduce the bandwidth in the IoT network. And but I would like to draw your attention now to energy harvesting. We heard it already before. And so you don't need necessarily batteries to power your IoT devices. You can also use the energy from the environment. You can use light, heat, or motion. And there are many use cases and applications out there, and one of them is the maintenance of offshore wind turbines. And if you are doing maintenance offshore, you can do it either with a vessel or with a helicopter. And this means that the worker has to climb onto this turbine and have to tighten a screw or to check the machine status, for example. Each visit will cost you around $10,000. So needless to say, this is a huge effort. And at Fraunhofer, we are working on technologies to reduce this effort of maintenance. So we have developed a smart screw connection called Cubo, which can be attached on any regular screw. And inside this module is a thin film sensor. And this detects if the screw is loose or not. But you can also monitor the condition of the wind turbine by vibration analysis and in combination with machine learning. And the interesting part here is, in relation to sustainability, that you don't need batteries here with this module. You can use energy harvesting. You can use solar panels or, for example, also thermoelectric converters. So this is one example for making IoT devices more efficient. But we have also another challenge. We have to think about ways how to transmit the data from the sensor to the gateway or to the maintenance operator. And one option might be LPWAN, low power wide area networks. You have the advantage to send small data volumes over many kilometers extremely efficiently. And well-known technologies in this market are, for example, narrowband IoT or LTE-M in the field of cellular IoT, or LoRa or Sigfox in the field of legacy LPWAN. But if you choose one of these technologies, you have always a trade-off. If you choose narrowband IoT, you have a great reliability in your transmission, but at the same time, you have a challenge with your power efficiency. If you choose LoRa, you have a quite good power efficiency, but you have a challenge with interference and with integrating lots of sensors in your network. So mioty combines both of these advantages. We have a 3 times better power efficiency compared with other systems, and which makes it most suitable for energy harvesting. And at the same time, we have a quite good quality of service. And as I mentioned at the beginning, it means in terms of extended range, interference robustness, and massive scalability. And why these performance indicators are so important for IoT, I will present you now. In this use case is in the field of metering. The customer is the municipality of Erfurt, and they have the challenge to integrate 30,000 water meters in their network in an area of 120 square kilometers. And these sensors are mainly installed in basement and in pits. So this means you have indoor or deep indoor requirements. And they were asking what kind of technology shall I choose to integrate, to connect all these devices. And therefore, and to answer this question, we compare different technologies, LoRa and mioty, and I will show you the results now. In the left picture, you see network planning, which was done by demetering, and the yellow pins represent the antenna locations. The green area is the coverage, and with LoRa, you need at least 40 to 60 antenna sites to cover this complete area to integrate 30,000 sensors in this network. We made the same test with mioty, and we needed only 17 antenna sites, 1/3, to connect the same amount of data. And the reason why mioty performs so much better in this use case is the interference immunity of telegram splitting. And with that, you can choose much higher antenna sites, and you get a much better sensitivity to, and this results in this case in a 3 times longer range. And the benefit for the end customer is quite clear. You get a much better installation costs. You can reduce your CapEx, considering that one antenna site costs up to 30,000 euro. But you can also decrease your OpEx because you have less rental costs, maintenance costs, and you can save energy due to the fact that you only need a few base stations in this network. And there was another question from Erfurt, which was, what happens if I integrate 100,000 of sensors in this network? For example, to add electricity meters, heat meters, or asset trackers. And to make it short, if you integrate 100,000 sensors in this LoRa network, your messages will be not delivered anymore. You have no service available because of the high self-interference of LoRa and the limited capacity. So don't get me wrong, LoRa is certainly a very good technology, but it was developed for point-to-point, so point-to-point communication, and not to connect thousands of sensors in a network. So with mioty, we can easily integrate 100,000 sensors in this network, and despite the high interference level. And this is one of the reasons why Erfurt and many other municipalities decided to invest in this new technology. Well, this is the status quo of mioty, and now I'm really looking forward to the next presentation of my colleague Raphael Wirz from Swissphone, and he's also the colleague in the mioty Alliance, and he will present you now new capabilities for new market segments which we are planning to address in the near future. Thanks a lot for listening, and Raphael, the stage is yours.
Thanks. Good morning. So let's first have a look at what is mioty capable today, and afterwards I will show the new capabilities, as Max said. So mioty has, similar to LoRa, different device capability classes. At the moment we have class Z and A. So Z is for monitoring. So you have ultra low power consumption, you have massive scalability, you have interference immunity. With class A, you can configure your sensors. Some examples in this area is smart metering, as Max mentioned before. You could do also water level measurements. You can do water leakage detection, condition monitoring, also the example with the screw before. So I would say 95% of the LPWAN applications are in this area. But what is missing now is like the communication. So you send an uplink, but you're missing the downlink capability. So you cannot control anything. So this will be the future step for mioty in the near future. We will add 2 new classes to the standard, so the class B and the class C. With class B, you're able to command actors within a certain time. You can send multicast downlinks and broadcast downlinks. So what does this mean? If we take the example from before, if you have detected a water leakage, you can now send a multicast downlink to your actor, so to your valve. And not only one, but you can send one multicast downlink to a group of valves. So it's much more efficient like this. You can also send a broadcast and close all your valves in case of a leakage detected. And then there is class C, where you can control at low latency your actors. And I will show you now one example, which we are developing at Swissphone, which is in the area of worker safety. We use different classes for this, so class B and C, and also Z, so a range of different ones. One comment, so the higher classes always include the functionalities of the lower classes, and you can mix different classes in one network, so you're not bound just to monitoring. So the use case I want to present you is the lone worker use case. So people working in industry, they work alone in risky areas. Nobody sees if an accident happens. So therefore, they can wear such a device, which is also shown there. And So this device, like this one, they wear it. If they don't move anymore, it's detected. If they fall down, you have a SOS button to press if you need help, and you can be localized indoor and outdoor. This can be used, for example, in industry, people working somewhere far away where nobody is, or for maintenance workers, for utilities as well. So as Max mentioned before, Swissphone is full member of the mioty Alliance, so we decided to develop this use case with mioty, and therefore we partnered with Fraunhofer-Institute. Of course, you need a base station and so on. What is now going on is if you have a lone worker accident, the device sends a low latency uplink to the base station, class set, and then the backend or the control center sends first responders. And how does they do it? So they send a multicast downlink to a group of first responders so they can help this poor guy. And in the same time, we send also the multicast downlink to a group of different signals, alarm signals to warn these guys. So this setup we have outside at the mioty Alliance booth. So please come by if you're interested to check it out. One last slide. So Swissphone has one product already available. So this before is a development project. We will finish this soon, but one product is the mioty base station, which is already available.
Thank you very much, Raphael. And please visit Raphael and, of course, Maximilian at their booth. They're happy to answer all of your questions at the booth.